going to eventually need to learn how to solve systems of inequalities instead of just equations. Before we do that, we need to make sure we know how to graph inequalities by themselves before we start putting 2 and 3 inequalities together. So remember, an inequality does not have just one single answer. So it has many answers or many solutions. So inequalities are like the less than and the greater than. There's a couple different things we're going to write off to the side here to remember all of these different things. So when we did this on a number line, if we had a less than or a greater than without the equal to part, we made an open circle. On a graph like this, that is going to be a dotted line. And then if we have a less than or equal to or greater than or equal to, so it has that equal to part, we had that filled in circle. Now we're going to have a solid line. And then another similarity was when we shaded to the left or to the right on a number line. We can't shade left or right on a graph. So if we have less than or equal to, we're going to shade below. And then if we have, well actually, or one more thing, or there's one special case. If we have a vertical line, there is no above or below. So if we have a vertical line, we're going to shade to the left. And then if we have a greater than or equal to, we're going to shade above. Again, except for that vertical line, there is no above. So it's a vertical line, we'll shade to the right. Other than vertical lines, we're going to follow those rules. Okay, so just like a regular equation, we need it to be in slope-intercept form. So we can see the slope, we can see the y-intercept in order to graph these. Number one, then I need to rewrite in slope-intercept form. I'm going to add x to both sides. Then I have y is greater than or equal to. I want my x term first. And I like to put the 1 there so I can see it. And then a positive 4. So my y-intercept is positive 4. We're going to ignore this point negative 2 here. It says graph each inequality, which we're doing now. It says then determine if the given point is a solution. So we'll do that after we have this graphed. So the y-intercept is a positive 4. It's right here. And then my slope is 1, which is really 1 over 1. So up 1 over 1. When we run out of room, remember we can also go negative 1 and negative 1 will be on the same line. So negative 1, negative 1, negative 1, negative 1. And I'm going to keep making as many points as I can to make a nice straight line. Okay, and then notice that I made a solid line, and that was because we had this or equal to. So then I know we make a solid line. And then, again, we're going to look at our sign here. So it's greater than. And we said that if it's greater than, we're going to shade above. So I'm going to shade up above this line. So the answer then, instead of just points on the line like an equation, the answer is going to be everything, every single point in that shaded region, and every point on the line because it's a solid line. So our second question up here says, then determine if the given point is a solution. So we have the point negative 2, positive 2. If I plot that point, negative 2, positive 2 is right here on the line. Because it's a solid line, then yes, that's included in the solution. So is it a solution? Yes, it would be. Number 2, again, you have to write it in slope-intercept form. So minus 2x from both sides. And now we have y is less than, with that x term first, so negative 2x, and then a positive 2. And we're going to graph this. So the y-intercept is positive 2. The slope is negative 2 over 1 to make it a fraction. So negative 2, positive 1, negative 2, positive 1 over and over again. Or I can also go positive 2 and negative 1. So positive 2, negative 1. And then before I draw my line, because I just have this less than and no equal to part, then I need to make this a dotted line. So this one's going to look like this. That means that any point on that line is not going to be included as part of our answer. And then for our shading, we have a less than, so it's everything down below the line. Everything below the line when we have a less than. So everything shaded in the red, not the line, would be a solution. So then let's plot our point. It wants us to check is 4, 2 a solution. So let's plot the point 4, positive 2. And because that is not in the shaded region, this is not a solution. So no, it's not a solution. Number 3, again, let's write it in slope-intercept form. So I'm going to add 4 to both sides. That's going to give me 4x plus 10, then divide. We end up with y is less than or equal to, because or equal to we have a solid line. 4 divided by 2 is 2x. 10 divided by 2 is 5. So my y-intercept is a 5. My slope is 2 over 1, but I can't go up 2. So instead of going 2 over 1, I can go negative 2 over negative 1. Negative 2, negative 1, negative 2, negative 1, and just keep repeating. And then because we have that less than or equal to, then I want a solid line. Less than means I'm going to shade everything below the line. So below the line is this way this time. So everything in that shaded red and everything on our line, because it's a solid line, is a solution. So it wants us to check the point 0, 2. So the point 0, 2 would be right here. Because it's in our shaded region, then yes, that point would be a solution. Again, rewrite in slope-intercept form. So minus 3x from both sides. Don't forget to bring that minus sign down with that 4y. And that's going to be negative 3x and a positive 4. Then we're going to divide both sides by negative 4. And then because we multiplied, or actually in this case we divided by a negative, I remember way back to chapter 2, if we multiply or divide by a negative, we have to flip our inequality sign. So instead of less than, it's now going to be greater than. And then negative 3 divided by negative 4 is, can't really reduce it, but I can make them both positive. So 3 over 4 positive x, 4 divided by negative 4 is negative 1. So my y-intercept is negative 1. My slope is positive 3, 1, 2, 3 over positive 4, 1, 2, 3, 4. And remember, positive 3 over positive 4 is the same thing as negative 3 over negative 4. So I can go negative 3, negative 4. And then before I make my line, it does not have the equal to part. That means I need a dotted line. And then I need my shading. Greater than means I'm going to shade everything up above the line. So everything in the shaded region is an answer, but the line is not an answer because it's dotted this time. So let's check our point. So I want to know, is the point 4, 2 a solution? So the point 1, 2, 1, 2, 3, 4, 1, 2, that is on the dotted line. Because it's on the dotted line and the dotted line is not included, then no, this is not a solution. So when it's on a solid line, like number 1, it is a solution. If it's on a dotted line, it is not part of the solution. And then anything in the shaded area will be part of the solution.